Hello everyone, welcome to my your programming club. Today we will be solving another daily lead code problem, and the problem's name is minimum number of k consecutive bit flips. Okay, so you will be given a binary array nums, and you will also be given an integer k. So there is a operation which is known as k bit flip. So what is what happens in this operation is that you choose a subarray of length k from the given array nums and simultaneously change every 0 in that subarray to 1 and every 1 in that subarray to 0. Okay, so you just basically flip the bits in that k size subarray of nums array. Okay, so this is known as k bit flip. So you have to return the minimum number of k bit flips required so that there is no 0. Okay, so it means that we have to somehow convert the whole array into array of ones, and we have to do so by using the minimum number of these operations which are known as k bit flip. Okay, and if it is not possible to achieve such a array in which all the numbers are set to 1, then you have to return -1 in that case. Okay, so a subarray is contiguous part of an array. Okay, so subarray can be like this, or it can be like this, or it can be like this. Okay, so it is a contiguous part of array. And let's have a look at the constraints also before thinking of an approach. So according to the constraints, the length of the array will be of order 10 raised to power 5, and the length of the window will be ranging from 1 to the length of the whole array. Okay, so now let's try to think of an approach to solve this particular problem. First of all, since it is mentioned that we have to flip the bits, so we will be making some observations regarding this. So if let's say we are talking about binary numbers, so let's say a bit is set to 0 and it is set to 1. So how we can flip these bits? So we want to convert 0 to 1 and 1 to 0. So we can do so by XORing these bits by 1. So there is a property of XOR. So if you XOR 0 with 1, it will be 1, and if you XOR 1 with 1, it will be 0. So a number XORed with itself, or a set bit XORed with itself, will result into 0. Similarly, 0 XOR 0 will also result into 0. So that is not our concern here. So if you want to flip a bit, the basic logic here is that you do it by XORing it with 1. Okay, so that is one observation. Okay, so flipping bit equals XORing with 1. Okay, so this is one observation. The second observation is, if you flip a bit even number of times or XOR a bit even number of times with 1, what would be the result? Okay, so if let's say I XOR 0 with 1 2 times, okay, so what will be the result? So this will result into 1. Okay, so now 1 XOR 1 is equal to 0. So you see, if the number of times a bit is flipped is even, then it will stay same, and if the number of times a bit is flipped is odd, then it will change. Okay, if number of times bit is flipped, then it will stays is even. Okay, so let's change it a little bit here. So if it is even, then it will stay same, and if it is odd, then it will change. Okay, or get flipped. So it's like you are having a coin. Okay, and it is having a green side on the top and red side on the bottom. So if you keep flipping this coin, if you flip this coin twice, you will first of all get this one as your first side will be your red side. Okay, then again if you flip, you will finally get the green side again. Okay, it is something like this. Okay, so I hope you are able to understand the observation still here. So what we will be doing here is, in order to minimize the number of flips required, we will be using the sliding window approach. Okay, so what we will be doing here is, we will be taking a, let's take the code also, so that the video remains, video times remains manageable, and it will not waste your time in understanding the approach. So let's bring the code also, so that it will save us some time. Let's take a fresh slide. So what you will be doing here is, let's say a array is given to you. Okay, and let's say the numbers are something like this: 0, 1, 1, then it is again 1, and then it is 0, 1, 0, 0. Okay, anything like this. So let's say you are at the very first index, you encountered that this is a 0, so you have to use your k bit flip operation. Okay, so what you will be doing here is, you will be having a subarray of size k starting at this particular index, and you will flip the bits. Let's say k is given to be 3, so your array will be, k subarray will be coming till here, or you can say a sliding window, you can say. So all the bits will be flipped, so it will come as 1, and this will be turned into zeros. Okay, now say after keep on sliding this window, you arrive at this particular index. Okay, you are checking for this index. Okay, you will, you know how you will be knowing that we need to flip this bit. So for that, you should be knowing that how many times this index have already been flipped. Okay, and what is the value of this index. Okay, so there will be two cases, and which will further have two cases. So the value of current index, value of current index can be either 0 or 1. Okay, and the number of times it have been already flipped. Okay, the number of times it have been already flipped. How it will be already flipped? Because of use of these windows. Okay, so if we talk about this, when we will be arrive, first of all we were here. Okay, now second number that we will be visiting is this one. So how many times this number have been already flipped? So you will say that it have been already flipped one time. Okay, and its value is also 1. So but for that, what you will be checking here is, you would be checking that what is the parity of the number of times its uh, value was flipped. Okay, so if the parity is even and you are having a 0, then so there will be some cases. So parity of the number of times it have already been flipped. So if you flip a number even number of times, so what would be the result? It will nullify everything. Okay, so if parity is even parity, if 0 is flipped even number of times, it means that it will still be a 0. Okay, so you need to flip it because we want arrays of all ones. So in that case, flipping will occur again. So this index will be the starting point of a new window. So this index will be starting point of a new window of size k. And if the parity is odd, so it means that 0 have been already changed to 1. Okay, so it will be 1 in that case. So we need not to do any flipping operation. Okay, same is the case for 1 also, with a little modification, that if the parity is even, okay, in that case you will not do anything. It means that it stays 1, and we all also want 1, so we won't be doing anything. But if the parity is odd number of times, the number of times this uh, index have already been flipped is odd, then you will say that it have already been converted to 0. So we need to start a new operation from here. So this index will be the starting point of a new window of size k. Okay, so I hope you are able to understand. So what we want that every number should be 1. Okay, if the number is 0 and you have already flipped this 0 number even number of times, that means that we need to flip it again. Okay, if the number is already 1 and we have already flipped it even number of times, then we need not to do anything. Okay, so these will be the cases. Okay, so this is how you will slide a window of size k, and one by one you will check for the each of the index. Okay, so this flip count will represent how many times the current number will be flipped, already have been flipped, how many times the current index being visited, you can say, have been flipped. Okay, why flipping occurs even before arriving at this particular index? Because there might be some previous indices at which flipping have been done, and the effect of those flipping would have been passed down to this index. For example, if you were at the first index, you see that it was a zero number. Okay, so let's clear this out. So let's say you were at this index, so you decided that okay, it's a zero, so we are going to flip it. Okay, but along with this particular index, you will also flip the subsequent index, because the operation is a k bit flip operation, so you have to flip other k minus 1 bits also. So since k was 3, so you will again flip other indices also. Okay, so let's mark the indices 1 2 3 4 5 and 6. So you will flip these indices also, you know. And you know, whether you want to flip it them or not, that is not our concern, but this k bit flip operation works in this way only. Okay, so we, at each particular index being visited, we need to know how many times it have already been flipped. So this current window flip count represents that thing. Okay, and total flip count is nothing but the number of flip k bit flip operations that you have to do. So this is what you will be returning. Okay, I hope till now it's clear. Then proceeding further, so you will be visiting each index one by one. So what you will be doing here is, let's write it somewhere. So for each index, you will check for two things. Number one is the value at that index. Okay, the second one is parity of number of times it have already been flipped. Parity of number of times it have already been flipped. Okay, so this is what you will check for each index. So you are visiting the whole array from left to right direction, and this window will keep on sliding. So what is the role of this window? So the role of this window is that it will help you to keep track of the parity of number of times a index have already been flipped. This is the role of this window. Okay, and it will also help you to determine the scenarios in which the all the array cannot be converted into an array of ones. Okay, so this is the role of this sliding window. So then what you will be doing here is, first of all, you will check if you have already a size of window k, and after sliding it to the current index, have you left something on the left hand side? Okay, this is the left hand side. So if let's say the previous start, so have you made a, you know, flip on the index represented by the starting point of the previous window? Okay, so the window will progress like this. So the new window will be starting from here and covering these two. So you will be checking, have you flipped this window? Okay, so if you flipped this window, flipped this index, previous start index, which might have been the possible index at which flipping have been started. So if you have flipped that window, then you will flip that index, then you will, you know, mark uh, to there. So if we have done flipping here, we will change it to 2, indicating that okay, this index was the starting point of a k bit flip operation. Okay, so in that case, you will say that current flip count will be reduced. So what it essentially means is that the effect of the previous flipping operation is reduced by 1. Okay, so here the effect of previous flipping operation will not reach, at least this flipping operation will not reach 1. Okay, so this is what we are saying here. So as you see, these two will receive the effect of the flipping operation done on the 0th index, but the third indexed one will not receive that effect. So that's why we are reducing the effect of the previous flipping operation if it have been done at all. Okay, so here we are reducing the effect of previous k bit flip operation, reducing the range of effect of k bit flip operation. Okay, so what we'll be doing further is we will be checking for the two things that we already discussed: the value of the current index, or value at the current index, and the parity of the number of times it have already been flipped. So this will give us the parity of number of times it have already been flipped. Okay, so as we talked about, if the number is 0 and the parity happens to be a even parity, then you need to do a change. Okay, this comes out to be 0, then you have to do a change here. And if this thing comes out to be 1, the parity comes out to be 1, and the number is also 1, then it means that 0, this 1 have already been converted to 0. So we need to do a change here. Okay, do a flip operation, k bit flip operation here. Okay, so in that case, first of all you will check. Okay, so we are doing a flip operation, so it means that this particular index will be the starting point of a k bit flip operation. Okay, for that we are sure. If we are not able to do the k bit flip operation at all, if the size of the window is larger or exceeding the size of the window, size of the array, so the situation will be something like this. So as you can see, the size of the, if we do a k bit flip operation here, which is k is equal to 3, so this much part will be exceeding the size of the array. So in that case you will be returning -1, indicating that it is not possible at all to convert all the entries in the nums array to 1. Okay, if that is not the case, then we will proceed further. First of all, we will indicate that this index is the starting point of a k bit flip operation and replace its value by 2. Okay, and then we will also increment the number of flips. Okay, so the number of flips is the number of times each index is flipped in the current window. Okay, and you will also increment the total flip count. Okay, so it is that simple. And once you are done with all this, you will be returning the total flip count. Okay, and this will be your answer. So if you are still not clear with it, try to rewind a video a little bit and revisit the whole scenario. So what was the approach here is, we were checking how many times a number have already been flipped before we have arrived at that number. So this was a greedy way of doing it, in order to ensure that we are using the operation, k bit flip operation, minimum number of times. Okay, so this was the whole approach. And if we talk about the complexities, time complexity wise, if let's say the size of the nums array is n, then it will be order of n. Okay, since we are doing a linear traversal here. And space complexity wise, as you must have observed, it is constant. Okay, so these are the complexities. So this is the whole approach, and these are the complexities. If you are still having any kind of doubts or any queries in general, then please feel free to ask them in the comment section. And I hope this solution walkthrough added some value to your journey of honing your DSA skills. And until then, keep solving more problems, keep practicing. I will see you in the next video. Thank you for watching.